Welcome back to Quest Edu Physics students. In this edition, we are going to learn about how to read the error in vernier calipers. I repeat students, how to find the error or how to read the error in a vernier calipers. In previous video, we have learned that what is the construction and as well as the working of a vernier calipers and what is the importance of them. Okay students, if you use a common scale, it is calibrated in inches and as well as in centimeters. And the least count, the minimum value, which can be measured accurately by using a main scale. That means what common scale is 1 mm because it is calibrated in mm only, in millimeters. If it is required to measure less than 1 mm, the two accurately and with precision, we need one more scale which is invented by Pierre Vernier, and it is known as vernier calipers. And already you have learned the least count of a vernier can be had as 0.1 mm or 0.01 centimeter. That means what? 1 by 10th part of the mm can be measured accurately by a vernier calipers. It is a very, very important thing what we have to remember. Okay, students. Then after, we have to know what is the error in instrument is. Okay. It was this diagram. It is the schematic diagram of a vernier calipers. If it was this, okay, students. See, it is the vernier scale, and the upper one is the main scale. If you watch it closely, the zero of vernier scale is coinciding with the zero of the main scale. It means anything which looks like this. That means what? Zero is coinciding with the zero, doesn't have any error. Okay, students, how we will find? See, if you take a vernier calipers, say it is the main scale and it is the vernier scale. See here, the zero is coinciding with the zero. Means the thing doesn't have any error in. Zero is coinciding with the zero. That means what? If you go on, okay, we are sliding it to some extent. This one, here we slide it and we kept an object in between. Okay, students. That means what? We can measure directly the measured length of any object with this instrument. Means what? We should not go with some addition or subtraction of the readings. Vernier scale is coinciding with main scale, means it has zero error in. Zero. It means we don't need to alter the values what we have taken by using the vernier calipers. Then we have to know one more error. Actually, there are 3 errors. Okay, in vernier calipers. One is the zero error, already you learned. The second one is known as the positive error, and third is known as the negative error. We have to how to identify, does it have a positive error or a negative error? See this diagram, students. Here, see this. Here, what's happening? The same thing, it is the vernier scale and it's the main scale. See, it is the zero of the main scale and it is the zero of the vernier scale. If you watch it carefully, you will understand. See, compare these diagrams, this one with this. The zero of the vernier scale is behind the zero of the main scale. Or simply we can say the zero of the vernier scale is not at all coinciding with the zero of the main scale. That too it moved towards the right side. See, is the right side. Then this kind of error is known as the positive error, students. Okay, this kind of error is known as the positive error. In this way, you can identify, does it have the positive or negative or the zero error. Zero is very simple. See, vernier scale or vernier zero is coinciding with the main scale zero. It doesn't have any error in it. Okay, the reading don't have any error in it. But see, here in this one, what happened? Vernier 0 is not at all coinciding with the main scale 0. Such error is known as the positive error. It can be identified very easily. Is it the negative or the positive? The simple answer is, if the 0 of the vernier scale is towards the right, okay, towards the right, then this error is known as what? Positive error. Here, in other words, if we draw the schematic diagram in this way, okay, is the main scale and it is the vernier scale. This one is, you see, it is the main scale 0 and it is the vernier scale. See here. Okay, it is the vernier scale 0. It is the main scale 0. They are not at all coinciding. This one is known as positive zero error, students. Okay, and how we have to take the reading? See, let's say, and you know that 10 equal divisions of vernier scale, 10 equal divisions of vernier scale are equal to 9 equal divisions of the main scale. Here I showed the same thing. Okay, least count is equal to 1 MSD minus 1 ESD. That means what I am trying to tell here. Here, when we are calibrating the scale, okay, I mean, when the scale is made, when they are calibrated, what they do? They take 10 equal parts of the vernier scale must be equal to 9 equal parts of the main scale. It means 10 vernier scale divisions is equal to 9 main scale divisions. Okay, students, 10 vernier scale divisions are equal to 9 main scale divisions. Okay, students, let's take here how to identify. I'm telling. What's this? It is 0, we have to leave it. It is the first reading, it is the second, it is the third, it is the fourth, the fifth, it is the sixth, it is 7, 8, 9, 10. Okay, now what is that? Observe. Which of these lines are coinciding? I mean, which of the vernier scale lines, that means divisions, are coinciding with the main scale divisions? See, this 0 is not at all coinciding. Let's see the first one. It is not, it is in between the second and third divisions, okay, of the main scale. That means it is not coinciding. See this, it's also, it is in between somewhere. And see this, and see this, and was this. It is the fifth division of the vernier scale is coinciding with one of the divisions of the main scale. Here I showed it is a 0.5 centimeter of the main scale. It doesn't require. Whatever the reading is, maybe it is the 6th or 7th, we have to take the vernier, what's that, reading, which is coinciding with the one of the, what's that, divisions of the main scale. Here, 5th vernier division is coinciding with the main scale, whatever it is, main scale it is. Maybe it is the sixth part or the fifth or the fourth or anyway. And I am taking this 5 as n. N is equal to 5. Here n means what? Verniers coincidence. It is the Vernier's coincidence. Okay, this is Vernier's coincidence. And how we have to take the reading? Here, positive error can be written as n coinciding division multiplied with the least count. Okay, students, positive error can be written as Vernier's coincidence multiplied with least count. Okay, students, here n is equal to 5. 5. Okay, students, and what we have to take? Least count. Least count of the instrument is equal to how much? 0.01 centimeter. Positive error is equal to how much? 0.05 centimeter. The positive error is 0.05 centimeter, students. If it is the error, it must have a correction. Now listen my words, students. If any instrument has the positive error, then the correction could be negative. Okay, students. If it has a positive error, the correction might be negative. That means what? We took a measured value. For example, you say the measured value. Here, when something is kept here in between, is equal to 1 centimeter. See, from here to here. Okay, then the measured length x is equal to, here I am taking an example, 1 centimeter MSR plus VSR into LC. We will take this reading. Okay, we will get a value here. 1 centimeter plus VSR into LC. Yeah, VSR. We will take, let's say, scale reading. There's a 0, leave it. 1, 2, 3, 4, 5, 6, 7, 8. One of the reading might coincide. 1, 2, 3, 4, 5, 6 reading. Means what? From here, 1, 2, 3, 4, 5, 6. Okay, and least count we have to take. You know that. Here from this reading, you have to subtract this value. From the total reading, you have to subtract this value. Then it is known as, what is that? Actual reading. X is the actual reading. Okay, students. See, it is the 1, 2, 3, 4, 5, 6th division is coinciding. Then the reading can be written as 1 cm plus 6 into least count 0.01. Okay, students. And what we get? It is 1 cm plus 0.06 cm. And it is 1.06 cm. Okay, it is the actual reading, measured length, students. Then we have to go with the total reading. Here in positive error, what we have to do? It is 1.06 minus 0.05. All the values are taken in centimeter only. Then what we get? 1.01 centimeter is the actual length. In this way, you can use the positive error. If the error is positive, you have to go with the correction, negative correction. Positive error It means instrument needed the negative correction. It needs the negative correction. Okay, students. Let's talk about the next one. It is the negative error, students. This diagram is showing the negative error. The students. How to find the negative error? It is quite opposite to this. See, if the zero is towards the right side, then we call it as the positive error. You see, the zero is towards the left side of the main scale. Zero is towards the left side of the main scale. Okay, students. This error is said to be the negative error. If it is towards the right, it is the positive error, and towards the left, it is the negative error. Okay, students. Now say, I'm taking n as number of vernier divisions. Okay, as you know that number of vernier divisions are, what's that, 10, which are in equal, what's that, equal to 9 divisions of the main scale. And already I told you, n is the vernier coincidence. Okay, students, here n is the number of vernier divisions and capital N is the Vernier's coincidence. And we have to go with the negative error. Okay, what is negative 0 error? What's the formula, students? It is minus of, it is minus of, what's that? N minus n into least count. N into n minus of n minus n into least count. What's this? Here in positive error, directly we measure vernier coincidence with the least count. Is a positive. Okay, students. In negative 0 error, what's this? Minus of number of vernier scale divisions minus vernier coincidence multiplied with the least count. Here, let's see, students, how to take the negative 0 error. We are talking about that. Let's check here. See this, 0 is in front of the main scale 0. That means towards the left side. That means it has the negative 0 error. I told you about this formula. To go with the negative 0 error, you have to use the formula that is minus of n minus n into LC. What is the small n here? N is number of vernier scale divisions. Obviously, they are 10 in number. And n is the vernier coincidence. Let's see what is the vernier coincidence. See this is the 0, is the 1, 2, 3, 4, 5, 6, 7. Okay, students. It is 1, 2, 3, 4, 5, 6, and 7. Is the 7, is the 8, it is the 9, and is the 10. 7th vernier division is coinciding with one of the main scale divisions. Means what? Vernier's coincidence is equal to 7. Let's substitute the value here. It is minus of n is equal to 10 minus 7 multiplied with least count 0.01 centimeter. This n and don't have any units. 6 is a pure number. Then it can be written as minus of 10 minus 7 is equal to 3 into 0.01 centimeter That is minus 0.03 centimeter. Okay, students. The negative zero error is equal to how much? 0.03 centimeter. And what is the correction? We have to add. If it is a negative zero error, the correction should be positive. Okay, same thing we are doing. You see, in total reading here, we subtracted. Okay, students. Here in this one, what we have to do? We have to add. It is how much? 1 centimeter plus 0.06. 1.06 centimeter is the reading. Then it has the negative zero error. You have to add that. You have to add this. It means what? Plus 0.03. It is 1.09 centimeter. In this way, you can correct the negative zero error. Or simply have to remember that if an instrument has the negative zero error, then the correction is positive. If the instrument has the positive zero error, then the correction is negative. Okay, students. It is the method to read what is the zero error in a vernier calipers. Okay, those who joined in this video can learn about the construction and working of the vernier calipers in my previous video, students. Thank you for joining with me. If you like the video, please subscribe and forward to your friends.